Okay. Today I'm going to continue with my project to do a code generator for my coding language that outputs higher performance Rust code that can then be compiled to a static DSP graph that is the same DSP graph as the dynamic one that the live coding language produces. Last time I did some preparatory work, mostly just to get my intermediary representation of the live coding language to a point where it had all of the data that I was going to need to generate the code, as well as all the data necessary to generate the dynamic version of the graph, just slightly different. So I think that is probably the easy part of this project. And today I'm going to start on the rest. Okay, so the next sort of preparatory step for this is to make sure that I have the code, the snippet of Rust that represents each of my modules or my nodes, the way my code is set up is this macro could be called from any code that is linked to the current executable. So this is sort of my standard library of nodes, but like you could potentially have an executable with other libraries that also register their own nodes. And so I can't know in advance what all the nodes are. Like I don't have a num of all possible nodes. And so I need to know from this macro the code that I will have to run in order to instantiate whatever node this represents. And basically I've already got that in the macro. And I think it's just these things because those are just Rust. And they tell currently they tell the dynamic thing how to build that node. But I think I could just take that, emit that as a string during code generation, and it will tell my static version how to make that node also. So that's going to be pretty straightforward, I think, but I need to collect that data. Because currently this is the definition of that macro, which you can see is very simple. All I do is I take the name of the string, so the static name, which is, I take the name, which is the string that will be used in the live coding language to reference this node constructor, and then this unique thing, which I can't actually remember why I needed that, but it was important somehow. It's because I have to use the link me library. I have to make these statics, and the static has to have a name, and concatenating identifiers in Rust macros is, I don't know. I'm sure you could do this better, but this was just easy. And then the actual code. And the actual code is this here. So the question is, I also need, what I need is I need to also store this as a string. And I sure am not certain how to do that. So starting point is so that's what it's going to look like. I just need to figure out what some code is, and then I need to change my definition of the registry, which is up here, I think. No. What is it called? Modules. There it is. So here's my definition of the registry. This distributed slice, and it is currently a static string, a function that emits one of my boxed nodes. So that's the dynamic version, and then the static version is going to be a string that represents the call that this makes. think that makes sense. Why don't you like that? Mismatch type expected. Why is that? And I just changed that definition. Oh, because I need to do this here as well. Okay. All right. So now I just need to figure out what that string is. So really, I know what the string is. It's this. But I need to stringify that. And maybe I'm just going to remember this off my top of my head. It might just be called stringify. Stringify? Because that's what I would call it. No. Oh. It for sure is. Or actually, I guess, if that's going to give me a static string, then I can just do that. And you're not going to like that because now this is wrong. Okay. That was super easy. Okay, so now I think I now have in my registry, I have the information I need both for the dynamic version and for the static version, which is awesome. That was easier than I was expecting, which is cool. Okay, so let's think about how this works. This file is huge and ugly. And what I'm doing is now a different thing, so let's make a new module. I'm just going to call it just to be simple. Okay, and this is going to use some things from the crates. At the very least that, which is my intermediary representation of the live coding language. Probably some other things too. I need modules to I have some code in the dynamic stuff that takes this line structure and built a graph out of it. But I don't actually think there's going to be that much shared logic between the dynamic version and the static version other than this data structure. So I'm going to start by ignoring that code and just writing from scratch, which I think is the right thing to do. Okay, so this is really not going to have any states or anything like that. It's just a function that takes the intermediary representation in and outputs a string, which I will then write to disk or something. So just do that, and it's going to take in a slice of these line guys, which should have some kind of name. And then it's going to output a string. Okay, I think that's my structure. I don't think I need any additional information because I don't really there's no global stuff. It should all be in that in the IR. So let's go. Okay. So I'm gonna think about some cases here. So okay. So what's my sort of my simplest case is going to be something like this. I have a node. It's got a name. It has a constructor, and it has a parameter thing. So in the back end, the code that this is going to generate will actually look like, since in the static version nodes don't have names, so that part's irrelevant. It's all in the graph structure. It's all in the topology. There's none of the other stuff. And then my sine wave is going to be table sine, and then this guy is actually a constant, because this wavetable takes in one modulation input, which is its frequency. In this case, a constant value of 220, and so that's like that. And then I connect those together with a pipe. So that looks like, okay, so that's the equivalent Rust code for that line in the live coding language. And so that string I just captured from the macro is this for the sine. And then this is one of my special cases that I was dealing with in the last video of these things that have parameters. And so that's something I'm gonna have to write some code for that special case, which is fine. And then this linkage is the pipe. And so I'll have to have some code that figures out how to structure that, because there's several other things that could happen there. Let's think of an example of that. So if I have a filter, it's going to be L. It's got a filter frequency, a resonance, a whatever that parameter is, and then on input, okay. And so in Rust, that's going to look like 3 constants. And then those first 3 constants go into, well, this one goes into a sine, so I'm going to repeat that structure from above. I'm partly doing this because I haven't actually written this layer in the code in a while, just, see if I remember. Okay, so that pipe now is a node that takes no input and outputs the signal from the sine wave. Right? Okay. I just remember, I think there's some preparatory work I need to do, because I left my currying code broken after the last thing I did. I may break the video today because that's out of scope for what I'm trying to record here. Whatever. So that's fine. Okay, so now I have the 4 inputs for the filter, and the filter is this guy. What are these called? CF. I think that's what it looks like. So that's my filter node. And then it needs those 4 inputs. and I guess I can do this without currying. So eventually I'm going to need the currying, but I think for this example I don't. So what that's going to be is I'm going to stack. Interesting. Previously, my topology stuff for building these graphs was all based on pairs, because that's what the values we're using. But now I've got the arbitrarily linked list, and so I think I might be able to write a nicer version of this. That's interesting. So if I could, I might do something like stack. So stack is a node that takes stack is not a branch. Branch is a node that takes some input, and I'm going to redefine it. This is not how it's currently defined, but this is, I think, what I want it to be. And a vector of nodes, all of which have the same input. In this case, nothing. But it could be like each of them could take a single float or something. And splits that input across all of them, evaluates them all, and then packs them together into a single output that is, in this case, 4 elements long. And then currently it only works pairwise, but I with the changes I've made to the code, I can make it work on vectors now, and that's going to be nicer. So that's a thing I'll do probably off camera. And then I'm going to pipe the thing that constructs into the actual filter, and then this entire structure is now a single node that takes no input and outputs a low-pass filtered sine wave, which, acoustically is not particularly interesting, but that is the thing I can build now. Okay, so that's the kind of code I'm going to be generating from this, and I think that was useful for me to think through that. Okay, so going back to this, I'm going to need to build up some information on what I've got in this file, because I have no guarantee about what order these lines are in. I don't know anything about them, so I need some structures. So we're going to get us some standard library and get us some hash maps, I think, for now. And so again, the final Rust output doesn't care about node names at all. That is just not a thing that exists in that world. That's strictly for the dynamic stuff. But in the live coding language, the names exist and are important because they're how I define the patches between nodes. One of the ways I define patches between nodes. So I have to keep track of them. So I need to organize these lines into a list of nodes and a list of connections between nodes. And then there's a little bit of additional information in there, which I'm going to think about later. So first off, we're going to get nodes, and those are going to be a hash map. And that's going to be a map of strings to some sort of node definition. Fine. Strings to, yeah, we'll figure it out. And then likewise, there's going to be edges, because this is, after all, a graph, and there has to be nodes and edges in there somewhere. Okay, so now we're just going to walk through the lines and build those maps. So for line and then line line could be a bunch of different things. Right now we are interested in the case where it is this. What is that? Line. Okay. That. Node. And then a node has a node name, a node type, and optional parameters. And then I have my one super special case, which is currently, which is a bridge node. Bridge nodes that has a input name and output name. And then I have edge, and edge is the source node, source port number, destination node, destination port number. Because I've had to sit down and think about which one's source and destination several times. Probably make that a struct variant instead of a tuple variant, so that you can name it. Okay, and then there is other stuff. What other stuff is there? Okay. Includes, I'm not going to worry about right now. Comments, super don't matter at all. Node definitions, I'm not going to worry about right now. And external parameters, this is like if I have a modulation source that is outside of the graph, like a MIDI keyboard or something, this is how I handle that. But I'm also just going to ignore it for the moment for this first pass, which gives me just the simple case of node, special node, and edges. And everything else is just, we're just not going to handle it. Cool. And these just don't do anything. So, okay, cool. So now these guys are going to go into the nodes. Nodes, insert, and my key is the name of the node, and my value is just the other stuff. So the string type and the optional parameters. And then how do I want to track the edges? I need to know, what do I care about? I think I'm eventually going to have to do a topo sort, and I do have code for that on the other side, which I may just reuse. Because that doesn't matter in cases where there's a one-to-one mapping with the output ports of one node and the input ports of another node. So in these cases, everything here, right, where I have, there's one constant that gets fed into one consumer, or a bunch of constants get fed into one consumer. In all of those cases, like I don't care. I don't need to do the topo sort. Like the structure of the graph is enough. But if I have something where if I take the output of this whole thing and split it among several different nodes, so basically any place where I split that value like that, then suddenly I can't express it this way anymore with just the topology. I need to write that value to a register somewhere so that I can sort of reinsert it into the graph at a different point. And I think in order to do that, I'm going to need a topo sort. So that still doesn't really answer my question. But I think it's think the destination is actually what I care about, so we're going to do this by destination. So look up the destination node. If that entry exists, just the name, I think. If it doesn't exist, or inserts with this method back, and then we're going to push a port, a source node, and a source port. So that gives me a hash map of lists where I'm saying every node, and then the list is all the stuff that feeds into that node with information about how that feed happens. I think that's how I want that. And then this guy is relatively simple. We're gonna insert. Is this true? Because this is the one where I have to build these together. I have to build a bridge. The bridge is two parts. They're linked together, and I have to build them at the same time and then do whatever I need to do with them. So even in this case, this might actually be a special thing. We will come back to that when it blows up. Okay, so this is what I need for my most simple of simple cases, I think. Before I go too much further, let me get set up to actually run these guys. Probably should be starting a test suite at this point because this is getting complicated, but I'm just going to build an executable I can run. So the only part of this that I actually need is the parser, and currently this is a method or a associated function on my graph, and I don't know, maybe that's dumb, but that's the only thing I need to run. It doesn't have any dependencies on anything else. It just takes in a string. So that's going to be pretty simple. So I'm going to go to my examples directory, and I'm going to make a new example called cogen.rs. And it's going to take instruments. That's the name of my framework. Going to need in dynamic graph. It's going to need the dynamic graph because that's the thing that's got the parser on it currently. And from cogenerator, it's going to need the toRust function that I'm defining. I think that's it. Why are you sad? Instruments cogenerator. What am I doing wrong? Cogenerator. Oh, I've got a typo. That's not a real module. Now it's a real module. Not included in module tree. I don't know what that means. Okay. So now I'm gonna parse a file, and I'm just gonna parse some static code for now. So it's gonna be line equals So we're going to give it a and there's my basic example. And that should parse. Like, that's not valid from the perspective of the run of the actual live coding runtime because it doesn't specify any outputs or anything. But I think it'll parse, and that's all I care about. So, and then we're gonna call to rest on it. So that equals to rest on those lines. And then just we're going to dump that to standard out. Okay. And then let's go back to the code generator. So this is, right now this does not actually run because it's not really returning anything. How about this? That's valid Rust. Okay. So now I should be able to test this once I've got it working. Not have to run it. Okay, so this should, I think, compile and run. Let's do it over here actually. And I called it CodeGen. So this should print the panic. Oh, I see. Okay, because I changed the definition of this module, so I need to do, what are you doing? You're building a hash map. And this other thing that you also don't care about. Okay. Expected slice. Okay. And this needs to return whatever. What result it needs to return. To use the question mark operator. Hey, and there's some Rust code. Okay. Not great Rust code, but you know, it's a start. Okay, but now we can pump that code and just sort of see what it's doing. Cool. Okay. So to start with, so now we know which nodes we have and what they're called, and we know how they're connected together. And that's a good start. So let's see, how do we go through this? We go, and basically I just need to go through and I need to collapse, sort of walk this graph over and over again, and every time I find an edge, I collapse it into the because basically I'm like the Rust version is going to be, it's actually a tree, except I've got these bridges that I can sort of connect. I can connect leaves together to make it a graph, but like the structure of it in the code is a tree. So I need to build that tree somehow. So if I just recursively like pick a node at random, and I'm trying to do this without sorting the graph, and maybe I can't. If I pick an edge at random, is that how this works? So if there's a node with no edges, that's a good question. What do I do with disconnected subgraphs? Because in the Rust code, those are just not going to be, anything that's not connected to the output doesn't exist. In the dynamic codes, they do. So if I go through the edges and I collapse all the edges, because I have the edges structured now as by destination. So maybe that's the right thing to do. So basically, yes, okay, I think that's right. So every entry in this map basically represents a line here. So like this is one entry in that graph. I mean, except the I guess it's not quite that simple. Okay, so that was not particularly coherent, but I think we can do it. So, okay, so let's say I just take an edge. So I'm gonna do this. Wall edges is not emptying. I'm gonna pick an edge, and the standard library hash map doesn't have a pop, does it? I hate that. I hate it so much that I'm going to take a dependency to avoid that. We're going to use index map. That's right. So instead of hash map, we're actually going to use index map, because this does have a pop. Yeah. There's certainly a better way of doing this, but it just my language server for some reason doesn't pick up new packages unless I kill it and restart it. I don't really know why that is, but next one doesn't have entry. I find that very surprising. I'm looking up some documentation. is index map is not what I think it is. Index map without the underscore. I added the wrong package. Do that again. Okay. All right, now I've got the right thing. Okay. So, and in fact, actually, I can do this. Do edge. No, what is this? An edge is a destination node and a back of and sources. Cool. Okay, so now I've just picked a destination out of the graph, and I know all its sources. So, wait, is this going to do what I think it does? You will discover over this probably very frustrating video that I'm not particularly good at this kind of thing. Let's see. Because this gives me, like, I can do this. I can say my node type. So I can say let's node type parameters equals node gets the destination node. Okay, so this, I look up what node this is and why it's interesting. This is always going to be present. The reference. Actually, I guess it might not always be present, but whatever, that can panic. For now, that's fine. Okay, because I don't know how to recover from that error, so panic is reasonable. And the node type is, I need to go to my modules. Okay, so actually this, let's just go here. I actually have some code already to do this, which is this guy. Because this modules is a list, but I want to look stuff up in it, so I want to edit a map instead. And we're gonna go here. In this case, what I need is, all I care about is the name, yes. I don't care about that function. I do care about the code. I don't care about this index, because I'm never going to come back to this list. Which means I don't need to enumerate that. And I don't need this anymore. Okay. So those are that's the code that I got out of my macro. And now I can get that code. So node code is module something node type. Again, it is not guaranteed. This is not guaranteed to not panic, but this is going to be running at compile time. And so actually panicking is what I want here, I think, because I'm going to be running this inside of a build script. and I want to kill the build if this doesn't work. I would like to kill it with useful error messages, so that's something to consider. But I think panicking is actually the right behavior here. Not satisfied. Something's double referenced. Sure don't want to think about that. Whatever. Okay, so now I have the code for this node. Okay, and let's just double check that this is getting stuff that makes sense. This should certainly work, but okay, that didn't do what I was expecting. Why not? There are no edges? There must be edges. There are no edges. What is that example again? Launch. Okay, there super should be edges there. Why are there not? Parsing out of that. A comment. Okay, somehow that's misparsing. But why? Let. That is not the right syntax. Although why it turned into a comment, I don't really know. Okay, that's what I was expecting. Okay, so this is a reasonable parse. Yeah, I have some anonymous nodes, which is expected, and then in the edges there's only one edge, and that's correct. It's from to this. That is the answer to this. Yeah, okay, good. That's what I expect. So, and then indeed I have two node code, and then there's my let's see. No, destination node. Right, because there's only one destination code, so that one part's like, okay, great. So I'm good shape here. Okay, so that's doing what I expect. So so now I have that wavetable sign, and I know that I'm going to need to pipe something into that. So let's, because that's what an edge means in the static world. So let's just continue not really thinking about this very hard and go, let's pipe equals it's empty, there'll be nothing. I don't know what to do in that case. If it has length of 1, otherwise don't know what to do there yet. Okay. And then, so I know I have a node with one input. The input's going to be something. The node is going to be this node code. Okay, and so what's the inputs? The input is going to be, I also have to think about the ports. Oh man, just the way the dynamic stuff thinks about nodes is a little bit different. This is going to take some unraveling. Okay, so in my simplest case, there's going to be one of these guys, and so it's got a source node, and I know there's one, so no, it's destination port, which I don't actually know how to handle that yet. The source node and the source port equals versus 0. Okay, and then I can also get the code for that. Call it something else. Source node code. No. I also need this. Source node. Whatever. Node type. I can shadow that here. That's fine. Okay, and then okay. So now I've written a really dumb special case that I think handles sort of one branch, but not very well. Okay, and then that. And then so instead of panicking, I'm actually going to omit that code. And then here I'm going to push stir, I think is how this works. Push stir code. I think that's how you do mutable strings in Rust. Okay, compiler's happy. And then because feels naked without the semicolon, even though it's with that still not valid syntax. Okay, that didn't work. No entry found for key. It's going to be this. Right, because the only source node I have is this, and that doesn't actually have. That's a special case. Okay, so let's just start by handling some special case. So it's going to be a match for type, and this is my fallback of it's not a special case that I know about, and the only one I'm going to think about right now is constant. In which case I have to construct the constant, and the code for that is, and here's where I care about the parameters, because for constants, my parameter is going to be node parameters number, because that's what the parameter has to be in this case. was dumb, and it was dumb when I typed it. Because this might be nested inside other stuff, so this is not the place to be putting semicolons in. That, if it's not that type, then I don't know how to handle that. So that means that this intermediate representation was badly constructed. Okay, and what does this need to be? This. Okay. There must be something there. This doesn't make sense to have a constant without a parameter. Okay. String. What do you expect it to be? Oh, it's because this is something. Okay. Okay. The ownership has to match. Okay, so that gives me, in the case where there's a constant, I build the constant with whatever number it's supposed to be inside. I can stick that in my pipe. Cool. Okay. So that is actually the Rust we would expect for that very simple input. So it makes pipe, it runs a constant into the pipe, runs a constant into a wavetable sine wave generator through a pipe. And yeah, cool. Okay, so that's super not useful yet, but it did a thing, and I'm starting to get a feel for like what this is going to look like. I'm going to end up rewriting this several times because it's just I don't understand how to do it well, and that means I just do it over and over again until it seems reasonable, because that is how I write code. So this is pass one of several, but it got me the code I'm expecting, and I'm pretty pleased with that. And with that, I'm going to break for now.